Hi grade 9s. Okay, so up until now, Mr. Ho has taught you people how to work with algebraic expressions and then he moved on to algebraic equations. So basically I'm using all of your knowledge that you already have on algebraic equations and we're taking it and we're translating it into the next chapter, which is on functions and relationships. Now remember, everything in mathematics is all linked together. Okay, so in functions and relationships, you guys are already familiar with this. You've been doing flow diagrams and spider diagrams and things like that. Also in grade 8, if actually from grade 6 and grade 7, you've been working through tables and where you have to fill in numbers and things like that. So all this video is going to do is just familiarize you with everything that you already know and give you a worksheet to do for revision. Okay, now as I was saying, everything with functions and relationships are all linked together. So if I have a particular equation, there's a number of ways that I can actually translate it. Okay, what do I mean by translate it? I mean the way I can represent it. I can represent it visually with a graph. I can represent it verbally by saying, for example, a number multiplied by 2 and then add 7 to it, so that there would be verbally. Or I can put it in a flow diagram, or I can put it in a table. And then the other way that we can represent it is with a formula. For example, y is equal to 2x minus 7. You're going to see that quite often. That's the example that I use throughout this explanation. Right? So that's a reminder on everything that you know up until now. Okay? Flow diagrams, how do they work? Okay? We have an input number that we're putting in. Okay? Then there's the whole bunch of operations that you're doing in between. And then we have an output number that you get out of it. Right? That you calculate. The number that we put in is not affected by anything, meaning that we can choose any number or there's any numbers given to us, and therefore it is called our independent variable. Okay, this is all the operations, and whatever comes out is the dependent variable. Right? Dependent means that it needs this operation here and it needs this particular number over here to give us this number. We cannot just get a dependent variable out of thin air. Okay, so I did an example over here which we're going to do together. I gave you a flow diagram and I've labeled it with X, all the numbers over here, and Y. You guys are all familiar with stuff like this, but I just put one so that you guys can see what we're doing and how it's expected to be marked, or how you're meant to do it in your test. All you have to do, if I've given you a number here, -2, you substitute it into the place of X and then you find your answer. Now you can write down all the calculations in your exam or in your workbook, or you can just, when we're marking, we're simply looking at your answer. So -2 multiplied by 2x, I'm going to do some calculations at the bottom. So -2, there we go, y is equal to 2 from there, multiplied by -2, which I substituted into the place of x, minus 3. And then we work this out. 2 multiplied by -2, we apply our rules of BODMAS. 2 multiplied by -2 is -4 minus 3. Therefore, y is equal to -7. All I'm then doing is filling it into its place. The next one, I have -5 as my independent variable. So y is equal to 2, open a bracket because I'm substituting in the place of x, -5. -5 minus 3. Y is equal to 2 multiplied by -5 gives me -10 minus 3. And then we can add and subtract. -10 minus 3 gives me -13. Fill it in. And that's exactly what we'd be doing for the remainder of this. This one here would be 2 multiplied by -7, which gives us -14. -14 minus 3 is -17. You can work that out. And then the next one, -2 multiplied by -9 gives me -18. -18 minus 3 is -21. And there we go. Okay. Okay, so now what we're doing is I'm giving you a question where they expect you to work backwards. What do I mean by that? I mean that they've given you already the output or the dependent variable, and they expect you to work out the independent or the input number. Okay, so for the ones that don't require that, we're going to follow the same method. Like for example, this 2, it's an input number, it goes into the place of x. So 2 multiplied by 2x, 2 multiplied by 2 minus 7 is going to be 4 minus 7, negative 3. Let me actually write that down. So for this one, it's going to be y is equal to 2 multiplied by 2 minus 7. So y is equal to 2 multiplied by 2 is 4 minus 7. Y is equal to negative 3. Okay, the next one we do the exact same thing. It would be, let's write on a separate page, y is equal to, from here I have 2x minus 7 and the independent variable is 4. So y is equal to 2 multiplied by the independent variable minus 7. Y is equal to 8 minus 7. Y is equal to 1. And we're going to fill that in on that side. The next value that is given is 6. So exactly the same procedure. Y is equal to 2 multiplied by 6 minus 7. This here is again that x value, it's the independent variable. Y is equal to 12 minus 7. Y is equal to 5. Okay, we're going to fill that in its place. Now for this one here, I've given you the 5 already. I expect you to work out this variable over here. So we're going to do exactly that. I have the equation y is equal to 2x minus 7. In the place of y, I know that it's 25. I'm copying it from there. And in the place of x, I know that it's m. So 2m minus 7. Like Mr. Ho taught, this here is an equation where we're solving for an unknown variable. So how am I going to do that? I'm going to take this, we're going to take it over. So 25 plus 7, and when we're taking it over, you change the operation. Okay, now please note that there isn't correct mathematical terms. In mathematical terms, you say you adding or subtracting or introducing the inverse, but for the purpose of this exercise, all you got to do is you say you're taking it over. Okay, you can work with that. It makes it easier to remember what we're doing. So 25 plus 7 gives me 32, which equals to 2m. And now the inverse of 2, because remember I want m on its own, the inverse of that is divide by 2. What I do on one side, I have to do on the other side. 32 divided by 2 gives me 16. So now I know that my m is equal to 16. And I can just go ahead here and fill it in. Okay, I'm going to leave the last 2 for you to do. So over here, we have 100. You need to find the answer over there. And this idea, I've given you the output value. You need to find the input value of n. You're going to try those on your own. Okay, let's talk about these inverse operations a little bit. I know that you guys have been doing equations, so you're quite familiar with them. Let's just talk about them quickly. For the opposite of a plus is a minus. So a plus and a minus are inverse operations. I have a multiplication and division are inverse operations. If I have a number that is squared, the inverse of it is square root. And note that we don't write the 2 over there in a square root. I just wrote it here so that you guys can see that what the exponent is over there is technically what the root is over here. Okay, so if I have a number square rooted and I want the inverse of it, it would be square. And the same thing for cube. If I have a number cubed and I want the inverse of it, I would say cube root. And if I had a number cube rooted and I want the inverse of it, I would say cube that number. Okay, so remember when we're going backwards from here, and then you're basically using or you're adopting the idea of inverses. You can, alternatively, if you didn't want to work it out, if you were quite smart and you want to do it mentally, you can go backwards like that mentally. Just don't forget that you're doing inverse operations. Okay, what do I mean by that? Like for example, this one where I had 25, all I have to do if I'm going backwards is I'm saying 25 plus 7, because the inverse of minus 7 is plus 7, and that there gives me 32. And then 32, here I have a multiplied by 2x, so the inverse of multiply is divide. So 32 divided by 2 would give me the 16. It's exactly what we did when we solved it, it's just if you wanted to do it mentally. I'm almost done, I promise. Okay, so we can take the spider diagram or flow diagram that we've been working with, and we can translate it into another format, right? Remember in the beginning I said that something can be represented, a relationship can be represented in a number of ways. So another way that we're representing it is in a table. So all I did over here is I took, as you can see, all of these numbers are our independent variables. I wrote it here for you, and they're the exact same numbers that I used from the flow diagram. And the same thing over here, the bottom values over here would be our dependent variables. When they give it to you in a table, they'll always give you an equation that you're going to use. Now there's two ways that we test you with tables. One is where we make you find the values that are unknown, or two, we give you a whole table of a whole bunch of numbers and we expect you to find the relationship between that. Okay, I'll have a separate video on that because that tends to get a little tricky. Okay, right, so nonetheless here I have the relationship between these two numbers, and I've given you the function. It is y is equal to 2x minus 7. All we are doing is we substituting the independent variables into the space that it belongs in, and the space it belongs in this particular case is x, and then we can work it out. I want you guys to be aware that this isn't always given with x and y. I can give it to you in a whole bunch of other variables. For example, I can use the variable for A to represent area, and I can give you length and breadth, or I can give you V to represent volume, and I can give you a whole bunch of dimensions, or I can give you a whole host of other real life problems. So please don't get into the habit where only x and y represent independent and dependent variables. Okay. And then lastly, this here can be represented as a graph. But we're going to talk about this later in more detail. I just thought I'd mention it. It's something new to you people. This exact same thing, y is equal to 2x minus 7, means something. So in one of the next videos, I'll explain to you exactly what this 2x represents and exactly what the 7 represents. That's all that I have for today. I'm going to put a worksheet for you guys to complete. And if you have any questions, you are more than welcome to message us on this platform.